META1 Coin for Humanity. META1 Coin. Technical Overview. META1 will use smart contracts for transaction validation. A team of blockchain engineers have developed smart contracts which work quickly and efficiently. Currently, there are also some issues with the original blockchain technology. For instance, the time to verify a transaction can be very high for a long blockchain. This time can increase further if thousands of transactions happen in 1 second. It is important to note that a large number of devices with blockchain nodes validate the transaction, but it also consumes significant time. Blockchain of Bitcoin needs validation for 51% of nodes to verify the transaction. This approach for transaction verification is also referred to as proof of work, POW. Delegated proof of stake mitigates the potential negative impacts of centralization through the use of witnesses, formerly called delegates. A minimum of 8 witnesses sign the blocks and are voted on by those using the network with every transaction that gets made. By using a decentralized voting process, DPoS is by design more democratic than comparable systems. A minimum of 8 witnesses sign the blocks and are voted on by those using the network with every transaction that gets made. By using a decentralized voting process, DPoS is by design more democratic than comparable systems. Rather than eliminating the need for trust, DPoS has safeguards in place that ensure that those trusted with signing blocks on behalf of the network are doing so correctly and without bias. Additionally, each block signed must have a verification that the block before it was signed by a trusted node. DPoS eliminates the need to wait until a certain number of untrusted nodes have verified a transaction before it can be confirmed. This reduced need for confirmation produces an increase in the speed of the transaction times. By intentionally placing trust with the most trustworthy of potential block signers, as decided by the network, no artificial encumbrances need to be imposed to slow down the block signing process. DPoS allows for many more transactions to be included in a block than either proof of work or proof of stake systems. DPoS technology enables cryptocurrency technology to transact at a level where it is complete with a centralized clearinghouse like Visa and MasterCard. Such clearinghouses administer the most popular forms of electronic payment systems in the world. In a delegated proof-of-stake system, centralization still occurs, but it is controlled. Unlike other methods of securing cryptocurrency networks, every client in a DPoS system can decide who is trusted rather than concentrating trust in the hands of those with the most resources. DPoS allows the network to reap some of the significant advantages of centralization while still maintaining some calculated measure of decentralization. This system is enforced by a fair election process where anyone could potentially become a delegated representative of the majority of users. Transaction confirmation time will be carefully addressed in Satoshi-based blockchain network of META1, and the trust will use DPoS for better performance. Blockchain can store huge amounts of data, as large data can reduce speed considerably. Therefore, an outside-the-network transaction will be required for quick execution of the transaction. Satoshi-based blockchain virtual machine, EVM, can help to build such an outside network. The working of these smart contracts with Oracle outside network explained beautifully in the IEEE spectrum, as shown in the diagram on the next slide. The user sends a request for plane insurance due to the delay of the flight. The request searches the previous data of the flight on Oracle outside the blockchain and determines the amount of premium. In the next step, the status of the flight is checked. If the flight is late, then the smart contract verifies the transaction of value equaling the premium amount in the account of the user. If the flight is on time, then a smart contract lets the system have the funds. The old blockchain is stored outside the main chain, and all nodes can only check new nodes for verification. This mechanism can increase the speed of the transaction. Example of smart contract working principle. Steps 1 to 5. All smart contract software which Meta1 has developed are built using Solidly and EVM, which can be decoupled from Satoshi-based blockchain public network and plugged into any other consensus mechanism. Most of this functionality is present in the smart contract which Meta1 is using for token insurance. The merger of Tendermint, EVM, smart contracts, and public blockchain can help Meta1 Coin to build a super fast and secure network. There should also be a contingency plan if the system faces any problem. In a scenario where a Satoshi-based blockchain runs into serious problems, Meta1 is willing to take full responsibility for possible network failure. And will take appropriate action immediately. So far, our recovery scenario for a Satoshi-based blockchain network failure looks like the following. Find the last valid block and launch a separate copy of the network that will start from that block.